Hello students, today in this video we are going to discuss about the interplanar spacing, which is a very important topic in crystal structure and in solid state physics. So today we will find out how to derive the interplanar distance equation. So what is interplanar spacing? It is the interplanar spacing or interplanar distance is the perpendicular distance between two successive parallel lattice planes. So it is the distance between the two perpendicular successive parallel lattice planes. Suppose for that we will consider a plane ABC plane which has a Miller indices HKL, which has a Miller indices HKL. So these are the ABC planes which has the Miller indices HKL. Now for orthogonal axis, the interplanar distance is equal to the normal distance between the origin and the plane, that is the first plane passing through the lattice points. So for that, now what we have to do is we have to draw one line from which is passing through the origin. So let the line ON is equals to D, that is it is the normal to the plane passing through the origin, which represents the interplanar spacing between the two consecutive planes. So this is ON, the normal plane. So this is the distance D that we have to find. Now we have to find the direction cosines, means angle made by the normal alpha, beta and gamma. Now this is the angle alpha, this is beta and this is gamma. So now we have to find the direction cosines, cos alpha, cos beta and cos gamma. Suppose if we consider ABC3 are the lattice constants, then we can have the intercept OA is equal to x intercept, OB y intercept and OC z intercept. We know that we are considering the ABC are the lattice constant and HKL are the Miller indices. So we can write it for OA it is A by H, for OB it is B by K and for OC it is C by L. Now we have to find the cos alpha, cos beta and cos gamma. For that we have to consider the triangle ONA. Look at here, ONA. This is O origin, O, N and A, this one. So for this, that is cos alpha is equals to ON by OA, that equals to ON is equal to D. We know that ON, that distance is D, divided by OA. OA is what? Nothing but here we have found that intercept, that is A by H. So just substitute in place of OA, it is A by H. In the same way we have to consider the triangle ONB for cos beta, that is ON by OB, that equals to D by B by K. Again consider the triangle ONC, cos gamma is equal to ON by OC, that equals to D by C by L. So from the property of direction cosines, we know that cos square alpha plus cos square beta plus cos square gamma is equals to 1. So we know the value of cos alpha, cos beta and cos gamma. Just we have to substitute here D by A by H whole square plus D by B by K whole square plus D by C by L whole square, that equals to 1. Now just to take a D square common, so what remains here? It is H square by K square plus K square by B square plus L square by C square, that equals to 1. So d square is equal to, we can rewrite this as 1 by h square by a square plus k square by b square plus l square by c square. Now for d we have to find the distance, so it is d is equal to 1 by under root h square by a square plus k square by b square plus l square by c square. This is the general expression for the interplanar spacing of the HKL planes. Okay, now for cubical system, we know that A equals to B equal to C. For the distance for cubical system, we have to use the same formula. This is the general equation for that interplanar spacing. That is 1 by under root h square plus k square plus l square divided by a square, because we know that a equal to b equal to c. So for that we can write this as a, this denominator goes to numerator, that will become a divided by under root h square plus k square plus l square. So this is the equation for finding the interplanar distance for the cubical systems.